Okay, so starting on 13 through 18 say find the measure of the indicated angle. Okay, so the first thing you have to know about doing this is, yes, it's different, but not the setup. We're going to set it up exactly the same way we did before. Now, the interesting thing about these problems that was not true on some of the ones you did on the worksheet is on these problems, all three sides are given. Okay? If all three sides are given and you're trying to find the angle, you really could choose whichever two sides you want to work with. In other words, I could work with the 12 and 9, I could work with the 15 and the 9, I could work with the 15 and the 12. Once I decide which two I want to work with, I have to figure out what they are and use accordingly the right trig ratio. So for instance, if I want to find, if I want to use, let's use 12 and 15. Okay, this angle, this is the hypotenuse for this angle. This is the adjacent. This is the opposite. So if I'm going to use 12 and 15, then I'm using the opposite and the hypotenuse, which is the sine. Okay, and I can do that if I want to. I can use really any two sides I want to. So I've chosen to use 12 and 15, so I'm going to use the sine. So I'm going to set up equation. It says sine of, and I don't know that angle, I'm just going to call it x, equals opposite over hypotenuse. Okay, now this is finding the angle. So these are the ones that if I want to get this away from x so that x is alone, I have to move it to the other side as inverse sine. This is the ones where I get, these are the ones where I get to type inverse sine in the calculator instead of just plain sine. This is the only type of problem where I do that, is if I'm finding the angle. So I'm going to do type inverse, which means second sine, inverse sine of 12 divided by 15. And that gives me 53.13. Usually we do to the nearest degree, which means a whole number of degrees, so that'd be 53 degrees. So x is 53 degrees. Okay, let me do another one. Let's say I'm doing number 14. Okay, for number 14, here's my angle. The 65 is the hypotenuse. The 16 then must be the adjacent, because your angle is always adjacent on one side and hypotenuse on the other side. Opposite is across from the angle. So now that I know which side is which, I can use any trig ratio I want to, sine, cosine, or tangent. Let's say I wanted to use tangent. Okay, then I would work with 63 and 16, opposite and adjacent. So I'd say tangent of my angle, which it doesn't have a name, so I'm just going to call it x. Tangent of angle x equals opposite over adjacent. And I'm trying to separate the tan from the x. So these are the special ones where, to get the x alone, I have to move this over here as an inverse tan. X equals inverse tan of 63 over 16. So that's when I go to my calculator. Sorry that I wasn't showing it. X is alone. Inverse tan of 63 over 16 is 75.7, so that's 76 degrees. Okay. If you don't like, if it confuses you that there are three sides and you can use whichever one you want, you're welcome to just mark one of them out, and then it would be just like the worksheet we did the other day. In other words, the one that says find the missing angles. You can just mark this off and say, okay, if I know these two sides, which sides are they? Which function do I have to use? That's fine. But you really have a choice, since we know that one. You have a choice about whether to use sine, cosine, or tangent. Now let me just talk to you briefly about 19 and 20. 19 and 20 is like a combination, 19, 20, 21, and 22. It's like a combination of what you did in 7 through 12 and 13 through 18. 19 and 20, both of them, you're given an angle, and you're given the 90-degree angle, and you're given a side length. So first thing you're going to do is you're going to find a missing side using sine, cosine, or tangent. Here I've got x written, so I'm going to try and find that one. Remember that an angle has two sides, and one of them is the hypotenuse, the other one's the adjacent. So on this one, I'm using cosine because it's adjacent and hypotenuse. So cosine of 68 equals adjacent over hypotenuse. We're going to cross multiply. The only time we don't cross multiply is like on 13 and 14 when we're trying to find the angle. X times cosine 68 equals 19 times 1. X is still not alone, so I got to keep going. I keep going until X is alone. Solving my equation. Now X is alone, and this is what I put in my calculator. 19 divided by cosine of 68. And I get 50.719, so 50.7. Okay, so X is 50.7. Now here's the deal. The difference between 19 and 20 and 7, 8, 9, 10, 11, 12 is that now I keep going for 19 and 20. I have this side is 19. I have the hypotenuse is 50.7. I still don't know this side over here. So I would use Pythagorean Theorem to find that side over there. I'm going to use some extra paper here. It's like I've got this. And I'll call this X now. So X squared plus 19 squared equals hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. That means I'm going to do this minus 19 squared. 50.7 squared minus 19 squared. X squared is 2209.49. Last thing you always do in the Pythagorean theorem is take the square root, and I get X is about 47. So this side over here is 47, and there's only one thing left to find, because now I have three sides, is that I almost have all three angles, but I don't. I'm missing this little bitty angle up here. So this is 90, this is 68, so this angle up here is 90 minus 68. Because remember, all three angles have to add up to 180. If I've already used 90, that only leaves me 90 for these other two. So 90 minus 68 gives me 22 degrees. So that's how I would also do number 20, is find X first, using sine, cosine, or tangent. Then find the missing side length using Pythagorean theorem. And then subtract from 90 to find the other angle. 21 and 22 are a little bit different because I need to find a missing angle first. I'll come back with those.